As I mentioned earlier, in this second part of this session, we will learn how to write equation of quadratic function, actually how to write equation of parabola. When we are talking about parabola, our general concept will be the same anyway, because we have to know coordinates of some points on our parabola, and then using those coordinates in standard form of parabola, we are forming simultaneous equations that later on we have to solve it. A parabola has two different forms. One is ax squared plus bx plus c, which we are calling a standard form, while the other one is y equal a x plus or minus k over 2a plus or minus k, which is a turning point form. So, sometimes our questions doesn't tell us which form to use to write equation of parabola. However, what we have to know actually, we have to know that if there are 3 points, then we will use this form. 3 points, but no one turning point. In that case, we have to use standard form to write equation of parabola. On the other hand, if we know coordinates of turning point, plus one more point, in that case we will use turning point form. So how to work in a case? Simply, if there are 3 points given in our question on a line on parabola that we have to write, then we are substituting x and y coordinates of each point in standard form to form 3 simultaneous equations. 3 simultaneous equations for a, b, and c, and solving those 3 simultaneous equations, we will find values of a, b, and c, and simply we can replace those values in our standard form, and by that we will finish question. We will have equation of quadratic function. On the other hand, if our question giving us only 2 points on parabola, but definitely one of those 2 we know that is turning point, in that case, again, substituting coordinates of turning point, x coordinate for h and y coordinate for k, in turning point form of parabola, we will form one equation. Then substituting x and y coordinates from the other point that is not turning point, substituting x and y coordinates of that point in equation after substitution of turning point, we will get one equation for a, and solving that equation for a, we will find value of a, and then we can come back again to turning point form to write a final equation. Anyway, this was like main concepts of writing equation of parabola in case when we know three coordinates of 3 points, or when we know turning point and one more point. We will see on some examples for each of those how that works. And it says, example, write equation of parabola that has a turning point at A. I'll write here anyway, A with coordinates 2 and minus 4. So this is turning point. And passes to point B with coordinates 1 and 3. So we have to write equation of that parabola whose turning point is A, but also another point B is on that parabola. So we said this to substitute in y equal A, x plus or minus, I'll write here still, h squared and plus or minus k. So this is h and this number is k. So this is horizontal translation, this is a vertical translation. Then we have equation y equal A, x, but horizontal translation is 2 units. Here it's plus, so here will be minus, always opposite sign. So here will be minus 2 squared, and this is vertical translation, this is k, minus, but also minus here, so vertical translation keeps the same sign. So minus 4. We need to find A. To find A, now we can substitute coordinates of point B. Remember, this is x, this is y coordinate. To substitute those coordinates in this equation for x and y, and then we can find value of A. We have y is 3 equal A, x is 1 minus 2 over 2 and minus 4. We have 3 equal 1 minus 2 is minus 1, minus 1 to the power 2 is plus 1, multiply A is A and minus 4. Minus 4 on the other side, and A is equal 7. Now, when we have A, simply we can go to substitute A by 7, and our equation will be y equal 7, x minus 2 squared and minus 4. This will be parabola in turning point form, whose turning point is A with coordinates 2 and minus 4, and another 1 point with coordinates 1 and 3 is on that parabola.